Hello, my name is Cameron Sabet, and welcome to Cutting to the Case. Today we're joined by Professor Lise Korsten, a South African plant pathologist and food safety scientist at the University of Pretoria, whose work spans fresh plant health, fresh produce safety, phytosanitary systems, international trade, and food security. Her early research focused on major diseases affecting citrus and subtropical crops and the post-harvest safety and quality of fresh produce. Her work later expanded into phytosanitary regulation and the technical barriers to trade, as well as food safety in informal markets and small-scale farming systems across Africa. More recently, her research has examined water quality and its role across agricultural and food systems. Beyond her research, Professor Korsten became the first woman to serve as president of the African Academy of Sciences, where she has worked to strengthen the role and visibility of African science. She's also a member of the Academy of Science of South Africa and has been recognized with an honorary doctorate from Ghent University and the 2025 NSTF South 32 Lifetime Achievement Award. Thank you so much for joining us today.
Good morning, Cameron, and lovely to be part of this discussion and just to share my journey. And hopefully, I can motivate someone to pursue their career and their dreams. So, I'm going to tell you my story, and I'm going to start small. And as a young toddler, I used to love playing in the sand and eating soil. And I think we have grown as a society into this very sterile environment that we think we should bring children up. I think COVID taught us the space of hygiene and sanitation, and that we have to be mindful of not interacting with each other. But microorganisms are everywhere. Nature selects. So the crux of the story is to allow our children to play freely in nature, to be exposed to natural elements. And we do believe today that to create a natural microbiome in your gut will contribute to longevity, health, and prevent several diseases such as dementia, Alzheimer's. So today, with science, we know much more. But when I was a child, it was acceptable to play outside and play in the mud. And I want to say the first thing is start small and allow your children to develop in nature, expose them to nature, and don't be afraid of germs. Then not every microbe is a bad microbe. So, and growing from that, I was always curious about the world around me. I loved nature, and I wanted to understand what was inside animals or plants or trees. And so curiosity is very important. And then never to stop dreaming. And so I was called a dreamer. And my father always said to me, don't make dreams your master. And I want to tell you today, my biggest asset is that I can think creative, I can integrate different sciences, and I can create very easily transdisciplinary research teams. So whatever skills you have as a child, as a young person, do not see that as an obstacle, but as an opportunity. And then, of course, I went to school, but at school, I realized I want to be a biological science, go into that science discipline and just be a scientist one day because it looked cool. And I think our educational system is not conducive enough to really encourage particularly young girls to select science as a career. But it does open many doors. And the most important is that you must focus and you must have a goal and you must go for your dreams and go and reach it. So as a child, I wanted to take biological sciences, natural sciences, maths, physics, all the STEM subjects. And I decided I wanted to go to university. And that was really the beginning of my story. So start small and empower young people, particularly people at school level, to find their little niche in life, what they want to do one day and what they will be good at, encourage and support them.
Hmm.
So that's really to me a first step in life.
Yes, yes, absolutely. And thank you so much. And if you could maybe redesign the institutions that educate young women and young people in general, what might you change?
You know what? I was looking at Japan and now in China, how they've changed the education system. I've also looked at Sweden and Norway,
Hmm.
and they have a total different approach with the preschool phase and the primary school phase. And they now allow, first of all, they lay the foundation for your basic principles, values. In Japan, the little children learn to clean their own classroom. They learn the basic principles of respect, trust, dignity, all those basic values that we want in society. And I think in the Western educational system, we've really moved away from those. And I believe it's very important. We need to rethink our whole education system. We've also tended in the West, I believe, to put people in boxes. So, we need to really create an open environment for young people, particularly for those who always think outside the box and they find it very difficult to fit into the education system. And
Mhm.
then we label them as stupid or the dumb kid in the class. In the meantime, they're the creative ones. And often we found at university, we see that your top performer at school is not necessarily the person who's going to finish his degree in time and end up doing a master's and a PhD. So there's no correlation between high marks achieved at school and being your top performer or your leader at the end. Um, so your average normal balanced kid usually does very well at university. So I want to say to anyone who feels a little bit the underdog or feel a little bit, well, I'm not performing so well at school, that it's just keep going
Hmm.
and believe in yourself and follow your dreams. I also look at the way they do in Sweden, where they expose the kids more to nature. They have classes out in forests. They expose children to that. And I don't know in cities how many parents take their children to parks or nature. In South Africa, our children grow up in game reserves. They know animals, they know birds, they play in the sand, they know plants. I think it's very important to connect with the earth and to lay a strong foundation for our children. So I think the education system, I think, is also a bit old-fashioned with AI and novel technologies. We need to leapfrog. And we need to be mindful how we bring it in. So I believe the educational system will need to change drastically to be fit for purpose for the future. And we have to change the teachers' training and the teachers' mindset. So we have a lot of work to do. And
Yes,
then we haven't reached university yet. We're just talking about primary and secondary education.
of course, of course. And are are African universities then, I mean, taking it a step further, producing enough scientists to meet the continent's needs, or is there a fundamental capacity problem happening here?
A crisis.
Hmm.
So we are not training enough PhD. If you look at the global standard for number of PhDs trained per in population globally, Africa is way below the global average. And that's not only disappointing, it is disheartening, and it means that governments throughout all the different governments within Africa will have to change their strategy by investing in our educational system to support particularly natural and agricultural sciences, your STEM subjects, and to create that environment that's conducive to enable that pipeline to run through from your school primary education into tertiary education. So there's currently an incredible gap between our educational system and tertiary education and leadership building. So we have a pipeline that's broken and we're leaking too many students that, first of all, don't have access to quality education, and secondly, do not have the supportive infrastructure. And we need to change that.
Mm-hmm.
And and then, of course, a focus on young girls and to encourage them to go into STEM subjects. So it's a crisis in Africa, and I believe that it needs a concerted effort from society to support our young generation to go into the science disciplines and particularly finish school and go into universities or technical colleges. But we have to change. We have to change now.
Yes.
That's a very important point.
Yes, and and another source I believe that is often cited for the crisis is the brain drain problem. How would you persuade more African scientists trained abroad to build their careers on the continent?
So we have a significant brain drain. We have a crisis in Africa in terms of middle management. So we lack senior scientist and associate professor level. So we have a gap. The gap is because we have lost so many students, promising students, usually at a master's level going into PhD. They would often go overseas to do a PhD or a postdoc, and then they don't come back. I have personally lost some of my best postdocs who got postdoc opportunities in the USA or in the UK, and obviously they do very well, and then they stay. So the question is, how do we attract them back? Um, it's not going to be easy to pull them back because they come from an environment where they have a very supportive ecosystem.
Hmm.
They have adequate laboratories. They have access to funding. They have a very supportive environment. And to attract them back to a fragmented science system, it will be a huge challenge. And usually, what we notice has happened lately is that your older scientist in the diaspora has this calling to come back to Africa and make a difference. So we are tapping into that. And it's usually scientists close to retirement. And they often decide to come back to Africa and spend that last pre or post retirement phase in Africa and invest back in their communities. So we're trying to tap into that to make it attractive to bring them back to Africa. And the big thing that we want to do now is to fund them and empower them to start research centers and support these young scientists so that they can stay and not leave the continent. And I think for any young scientist, if you know there's a career opportunity and there's a growth path for you with support, you will stay because we all want to stay in our own country, but we want a stable country. And that's very important for us right now. So there's a lot of initiatives funding through. We have, for instance, Kutla. It's a German-funded DART initiative, and we are investing in masters, PhDs, and postdocs. It's AI for sustainable food systems. And by doing this, we are sort of doing mobility grants. So you send a student across, they stay there 3 or 6 months, you bring them back.
Hmm.
So you're already benchmarking, you're training, but you retain the person in the continent. And I think that's very important. So it requires really an aggressive approach to retain our people, but you have to make it um, I would say science friendly, support, adequate support, but you have to link them into a network. And the best would be to have a strong global network with laboratories in different countries, and then they can still have mobility, but you retain them in the continent. It's the only
Yes.
way to grow.
Yes, yes. And when you when you speak about the constraints right now to advancing toward the PhD, is the bigger constraint today access to education, quality of education, or the lack of opportunities after education, would you say?
I think right now it's lack of opportunities after education. So a lot of students will do their first degree in, for instance, Zimbabwe or Benin. And then for them to go into their master's or PhD, they require good bursaries. But often their own supervisors at that institution does not have a good network. And if they have a good network, they can very easily get bursaries. And what I think would be the secret to unlock right now, if you can support the scientists, the early career scientists in the continent, and you give them access to bursaries for their students and mobility grants for them and for their students, so that if you almost tumble dry them between Africa and the North South, or Africa and the US, or Africa and China, but you have a system of bringing them back. And then, very importantly, they have to be co authors on publications because that publication journey is very important to awaken a scientist and to make him realize what a wonderful opportunity they have in science. And there's nothing like having your first publication. And often it's very difficult to break through that ceiling if you're a young scientist in Africa. But if you work with people in other countries from well-established laboratories, they often have the drag ability to pull you into that cycle. And once you're in a publication cycle, you publish more. So the first thing you want to do is publish as much as you can as early as possible in your career. And for that, you need to be part of a group that pull you in. And once you've experienced that, you can eventually you become the first author, and then you become the lead on projects. The second very important thing is to pull young scientists into project planning and writing research proposals, because that exposure is absolutely stimulating. And I'll give you an example. We have scientists from Brazil recently that contacted us, brilliant scientists. And there's a new Brazilian South African fund, collaborative research project. I immediately pulled my postdocs in and I said, here's an opportunity. It's an opportunity for you to grow. Let's jointly prepare the proposal. Now, immediately you're exposing that person to um, just an international network. And, going through that proposal writing is such an incredible experience of growth for a young person. And then, of course, the same, once you get the funding and you have to run this project, you work with a whole network of people and you master the additional skills of project planning, project management, financial management, accountability, um, ethics, open science, and immediately that person's mind start changing and they become more independent and they grow. But if you don't expose them to them and you keep them in a little silo, you're not investing in Africa and you're not investing in the next generation. So I believe this is the best time ever to grow a next generation of scientists because we suddenly have all these calls for collaboration, for having these networks, and it's the best way of unlocking the potential in Africa.
Hmm. And when you also speak about potential, if what should African universities look like maybe 20 years from now if the continent gets this right?
You're right. So, let's first put it on the table, infrastructure. We have a massive challenge around infrastructure, just mobility within Africa. You know, you may want to go to your neighboring country in Africa, but there's no direct flights. If you have to cross the border, it's a massive journey. Just remember the size of the African continent. You can fit the USA, China, Europe, India, all of it into Africa. So we are talking about vast distances. We are talking about a lack of connectivity in Africa, bandwidth, access to the internet, and then, of course, access to adequate electricity to run your laboratories, water. we don't have access to that. So your current situation with universities is that we have a severe challenge around infrastructure, including your laboratories, including equipment, including having access to chemicals, equipment. Often if I order chemicals, by the time it arrives, it's months. And then also, we often don't have an effective cold chain. So if you bring in certain enzymes or kits, often the break in the cold chain makes your test results questionable because you don't have adequate control around that. So these are just the challenges and obstacles. If you look at the future, with the current focus on investing in Africa's infrastructure, and I'm talking about a focus from Europe, a focus from China, Canada is talking about it, the UK. So a lot of people's realized we need to invest in infrastructure in Africa. That's roads, ports, etc. If we can get that, pull off that investment in Africa, and we can get better networks and collaborative projects and initiatives, I believe the universities would be able to transform within, I believe, a 5 to 10 year period. I also believe AI will be able to help us to more rapidly transform. And then thirdly, I believe that if we can bring back and retain a lot of our scientists, we'll be able to reform. I also believe the transformation of our universities will also depend on the network. So we have, for instance, the African Research University Alliance. You have your top 16 universities working together, and they have a collaboration. And what you do see is that the one university is sort of being pulled up by the next one, and they acquire specific skills, they have exchange, and I think we're going to see more of that. I think we're going to have more networks of universities in Africa, and I believe the universities might be smaller. Some of our universities are really massive. My own university is 65,000 students. It's a massive campus. It's a huge administrative task to manage that. And I believe that with novel technologies, we'll be able to have more satellite campuses throughout Africa. AI will also change the way we teach, and the way we do our research. And I believe it will enable scientists to also being fast-tracked. We don't have enough professors in Africa. We haven't benchmarked our degrees. That's another very important point. So it's very difficult for mobility because a student from Benin won't necessarily get accepted in my degree program in South Africa. We
Hmm.
first have to compare our degree, undergrad degrees, and the curriculum. We
Mhm.
need to calibrate that in Africa to get better mobility in the continent. And I believe the future vision of universities in Africa will be a lot of satellite that enables more people access into universities. Our training medium will be different. And I think the way we manage our campuses will be different. And I believe we'll have an open science structure in Africa
Hmm.
and lots of PhDs and professors.
Of course. Wow. And this open science approach is really incredible and an innovative approach in the context of
Yeah.
traditional African science. So, um, and if a well, I'd like to bring the conversation as well to your research, because it's truly fascinating. What you began your career in plant pathology, particularly diseases affecting citrus and subtropical crops. What first drew you to plant disease, and what were the major problems you're trying to solve?
Sure. So my first project was on avocado diseases. Now, avocado is one of those, um, I would say, best investments you can do in agriculture at the moment. So there's a few crops that's very popular currently for trade. And from a nutritional point of view, one is avocado, one is blueberry, the superfruit. The others are the macadamia nuts, and mango is always the superfood from heaven. So those crops, these crops are unique in Africa in the sense that we can produce a lot of high quality of that, enough to export. So we're very strong in export in most of these. And that's where my career started in avocado. And my career started with mango and then lychees and then citrus. And all of it was focused on export. How do we ensure that the fruit arrives on the European market in sound quality? And then secondly, how can we outcompete other countries? And we were specifically competing with Spain because we are putting fruit in the market that predominantly was the majority of fruit moving in Europe came from Spain, of course, unless you speak about apples, but citrus was very big in Spain. So we became an effective competitor in the European market because we could put our fruit, we could move it from the farm into the market in Europe within 42 days. We were in the shelves in Europe. And we could retain the quality. And that's quite unique. So my research was focusing on retaining the quality and preventing waste and losses. So I was focusing on diseases to prevent it and to develop natural biological control. So in those early days, I had one of the first biological control products that I developed as part of my PhD, and I could patent it. And those days we could, and register it, and was commercialized. And today, the whole world has shifted to a green economy, a green crop protection products, and it's very popular today. So the initial work was about trade. It was about developing alternatives to pesticides. And it was very interesting work. I loved it. And I still miss working in that field. So, so your sound, Cameron,
Sorry.
your
Yes.
sound.
Yes. For someone working outside the field, how much of the food that ultimately reaches our tables is shaped by plant pathology before we even see it?
I think everything.
Wow.
And the sad part of the story is that plant pathology is the least recognized occupation, and students never choose plant pathology because they're not aware of it. So we always try and tell students, if you become a plant pathologist, you're like a medical doctor or a veterinary scientist.
Hmm.
That's where One Health comes in. We look after the health of plants. And if you look at your current losses, it can be anything from 25 to 50%, even 70% that you lose. And a lot of it you lose in the field, particularly in Africa. But the longer your export chain or your supply chain, the more you lose. At every point you lose. And even on the table, you lose. Not everybody store the fruit correctly or consume it within its specific shelf life. And so we have a lot of food waste from the farm all the way to the table. And my specific discipline has specifically been to reduce the waste and losses, to find technologies to ensure uh, as little as possible losses in that whole supply chain. And very importantly, to understand the mechanisms that is involved in host pathogen interactions, how the plant pathogen attack the host, when it attacks, what triggers it, and what defense mechanisms is unlocked during this whole supply chain. So it's a very interactive dynamic process that's happening. Now imagine if more scientists would study plant pathology. I believe we could contribute significantly to food security. And that's why I work in food security, because we need to not only grow more food, produce more fruit, but we need to retain the food and ensure that it's healthy, nutritious, and safe. And that's sort of the phase of my life where I am now, to work from being a plant pathologist to being someone who's now working in food security and food safety, because it's all part of the plant health, the food nexus, very importantly.
Yes, yes. And when you speak about working in local areas as well. Food safety regulations are usually designed with safety as the priority, but can regulations where's the line between a legitimate phytosanitary protection and a technical barrier that unnecessarily excludes African producers from global markets?
Oh, that's such a hot topic. I love it. So the dynamic is as follows. Um, there is a lot happening in the space of not only pests, but also pathogens migrating. And with climate change, we're going to see increased migration. So we have two very interesting aspects. The one is the illegal trade, and with illegal trade moves pathogens. And so with illegal trade, people will move fresh produce or animal products or any product, food product, across borders. And a lot of people do not understand the importance and the dynamic of that. And if you go into Australia and New Zealand, it's most probably the best regulated of all the countries in the world. You will not enter Australia or New Zealand, and even in the questionnaires, they ask you when last did you visit a farm, etc., etc. So it's very important to ensure your phytosanitary competency in a country and effectively regulate your borders to prevent the illegal movement of plants. And it's not only plants; it's honey, it's all food products. And the public needs to understand that you cannot just move it because with it comes pathogens or insect pests. And we saw that with COVID. It's the same principle, it's just on a plant and a food level. Now, what is important is the normal regulated and the legal way of moving fruit. So you have trade agreements, bilateral agreements between countries where they then look at your pest list, your disease list, and we do risk assessments, we do phytosanitary risk assessments, and we assess the group and the cluster of insect pests or plant pathogens present in your country. And that then you can argue the point, I can export my citrus to your country because you also have the same pathogen there, and I will not introduce a new pathogen. And that's a very important point because if you can show that pathogen's already there and that government want to try and prevent you to export because they're trying to protect their own industry,
Mhm.
they will have to put forward scientific arguments why you cannot export. So we have these technical barriers to trade, we have these WTO agreements in place, and yet there's incredible competition between countries, underlying competition. But we also have collaboration. So we have the South countries often collaborating between South Africa, Peru,
Mhm.
Australia, and New Zealand in terms of avocados, for instance. We will look at when is the seasonal availability in Europe, and we will move our product into the north. And we will make sure we do not unnecessarily compete with each other, but that we work together. So
Mhm.
that's sort of harmonization that often happens.
Mhm.
The problem comes in if you have a regulated pest in your country. If you do not have the disease, so I'm going to use the example citrus black spot. So years ago, I worked on citrus black spot. We were exporting citrus to Europe, and in Europe, you do not have citrus black spot. And that required, therefore, that we had to put in phytosanitary measures in South Africa. We have to effectively monitor our orchards
Mhm.
for the presence of the pathogen. We have to have adequate spray programs to control it. And you may only export from areas where you do not have the pathogen or you effectively control it. And then you must show evidence that you do not have the symptoms present on the crop when you export it. So it's
Mhm.
a huge cost. The
Yes.
point is, it gets inspected in your own country, it gets inspected overseas. So by the time the fruit arrives in Europe, it's been through three, four, five inspections almost already, and it's highly regulated. So that system is working. But the minute the rules of the game start
Mhm.
changing and extra trade requirements come in or AGOA treatments fall away, market access becomes another challenge. So these Negotiations between countries to get market access is complex. It requires scientific input and it requires effective regulation and monitoring and inspection. And that's sort of a whole micro environment that you create. And there's politics involved, there's trade barriers involved, and it's amazing world, very complex. And I just want to mention, very important is climate change is changing the dynamics in that game. So when we prepared a report for WTO in terms of market access into Europe, in terms of citrus black spot, we were arguing that the pathogen will not be able to establish in Europe. The argument was, well, with climate change, the possibility is there that it could eventually establish. So suddenly your science had to be brought to the table to show that the impact of climate change, what's the likelihood of the pathogen being introduced, survive, and then become a pest in the country. So it's absolutely fascinating.
Yes, and you're modeling the disease over time and projecting that's incredible. And is there anything that, America can learn or American researchers can learn from the incredible South African model that you've kind of seen?
I want to tell you that South Africa is most probably, from a global perspective, the one country that has really been able to establish a very strong trade hub. I
Hmm.
mean, our country has been exporting fresh produce, well, for more than we've been known as the sort of the example globally of how you can establish an agriculture sector that can be a dominating world trader in terms of fresh produce. So we've got this incredible history, and we've exported peaches to Europe. We've got a long history of that. We have market access, we have built trust relations. So trade is not only about moving your product over and selling it, it's building up a trust relationship and building up a reputation of consistent quality fruit that complies with the highest standards in the world. So I want to tell you a beautiful story. I had a PhD student and we analyzed pesticide residue levels of fresh produce. And we looked at 6 years of data of all fresh produce exported from South Africa. And do you know we were the most compliant country in the world? We had a 98% compliance of not exceeding pesticide residue levels. That
Wow.
is unique, which shows you our farmers
Incredible.
follow these procedures, we regulate it effectively, and we
Mhm.
ensure that our produce on that markets comply, which
Yes.
means we've got a highly organized system and we're collaborating. And I think that's the lesson you can learn from
Mhm.
America, from the South African suppliers. So we have a trustworthy industry. We have an amazing industry sector. Our citrus industry, avocado, all these industries are incredibly strong and they embed it in a history of trade. They understand trade. You must remember what in the 1600s, the settlers who came to the Cape came as farmers to produce fresh produce for the ships going around the Cape. So they are by nature farmers and traders. They understand moving of produce and they understand how to grow it under adverse conditions. So that's sort of our background. And we have been dominating this export scene. I mean, in several of these crops, we're really a world leader. And I think that persistence and that incredible ability to, to ensure consistent quality at the market and compliant quality at the market is unique. And, we've been able to get market access into the USA with citrus. We've been able to get market access now into China with a lot of our fruits, and we are expanding our trade. And our fruit basket is unique in the world. Our quality is amazing. So it's really, I believe, the country of hope and of the future, and an incredible agricultural industry.
Yes. Thank you very much. And it is truly an incredible agricultural industry, and there's much that we can learn as Americans as well from the South African model. So thank you so much. And I always like the guests to have the last word here regarding uh, words of advice or inspiration for the next generation. If you could, speak to the audience, which is you're doing now,
Uh,
uh, what would you like to share?
Well, I believe Africa is the world's food basket. We have the land, we have incredible people in the continent, and we have so many challenges, but we can persevere. We're very driven, and we're very kind people. And I think I would invest in Africa. I would seek a future in agriculture and science. And I believe Africa is the continent of the future. And I would most certainly strengthen my bond and collaboration and network with scientists in the African continent and support the agricultural sector because we're going to provide food for the future.
Wow. Thank you so much. And what an incredible note to end on. I appreciate you joining today. This has been an honor.
Thanks, Cameron.
Thank you.
Thank you very much.
So this is
Thank
Cameron
you.
Sabet signing off.